My name is Jaya Choudhary, and I'm a 7th grade student at Canton Charter Academy.
Our planet is at the brink of disaster caused by climate change. The global temperature is predicted to rise 1.5 degrees Celsius by 2040, which will cause extreme heat waves, severe droughts, sea level rise, etc. The main cause of climate change is greenhouse gas emissions. Around 7 billion metric tons of greenhouse gas are emitted each year. In the United States, heating emits around 112.5 million metric tons of greenhouse gases.
The average furnace emits around 7,200 metric tons of carbon dioxide a year.
I wanted to see how much energy we were wasting in my house for heating. My hypothesis was that we waste a significant amount of energy by heating unoccupied areas. To find out how much energy we were wasting, I observed how much of my house was occupied while the heater was running. For a week, every hour, I recorded the occupancy of each room. Using the data, I calculated that around 56% of my house is unoccupied. I estimate that if we prevent sending heat to the unoccupied rooms, we can save around 40% of the energy, which would eliminate 45 million metric tons of greenhouse gases and save roughly $10 billion per year in the U.S.
Hot air from the furnace is sent to the rooms through these ducts, and the flow is controlled by the inline airflow dampers. What if we control the dampers with a robot?
To reduce the energy wastage, I've created an airflow control robot. It saves energy by only sending heat to the occupied rooms, senses where the occupants are in a house, and opens the dampers to let the hot air flow only to the occupied rooms. It uses a microprocessor to collect readings from all sensors and control servo motors. It uses a PIR sensor, which is a type of motion detector, to detect occupancy. It uses a temperature sensor to make sure the temperature does not go below a set minimum, and it uses a servo motor to control the inline airflow dampers. One of the future enhancements we have is to improve upon its occupancy detection. Currently, we use PIR sensors, which determines occupancy based on motion. However, this wouldn't work at night, when there's little to no motion while occupants are sleeping. Another idea was to use a camera, but they pose privacy concerns. I believe that collaborating with the 3M scientists will help me identify the proper solution.
Thank you for this opportunity.